Hi everybody, I welcome you to my presentation on voltage stability unit 3 part 1. I hope you have watched all my previous videos on voltage stability. The topics of unit 3 are analysis of voltage stability on single machine load bus system, analytical treatment and analysis, voltage stability indices, voltage collapse proximity indicator, determinant of Jacobian as proximity indicators, voltage stability margin. In this video, I am going to discuss about the first topic, analysis of voltage stability on single machine load bus system. SMLB stands for single machine load bus system. Let us move on to the topic. Here we are considering a single load infinite bus system. As you see here, this single machine load bus system consists of a single load which is fed by an infinite bus through a transmission line. Or in other words, we can say that transmission line connects both load as well as infinite bus. Voltage, magnitude and frequency are constant at the infinite bus. We are all aware about the definition of infinite bus. The voltage, magnitude and frequency will be constant. Infinite bus is represented by an ideal voltage source. The equivalent circuit is represented here. We could see that transmission line is represented by its series resistance R and reactance X. Transmission line impedance, that is Z, is given by in terms of R and X. It is a complex term, R plus JX. Let me explain clearly the derivation of voltage in terms of P and Q. We are aware that Z is equal to R plus JX. There are a lot of assumptions. One of the assumptions is that R is negligible when compared to X, as X value is high when compared to R. So R is neglected in that equation. Let us apply Kirchhoff's voltage law to this circuit. We are all aware that the voltage around closed path is equal to 0. In other words, we can say that voltage rise is equal to voltage drop. What is voltage rise here in this equation? E vector, it has got magnitude as well as angle, that is E angle 0. And voltage drop is nothing but the drop in the transmission line and the voltage at the bus voltage, load bus voltage. So therefore, we can write it as E is equal to V plus JXI. Now rearranging in this equation, one can write V in terms of E. Therefore, V is equal to E minus JXI. I hope you are able to follow this equation. Let me repeat once again. From the previous equivalent circuit, after applying Kirchhoff's voltage law, voltage rises E vector, that is equal to voltage drop V plus JXI. JXI is the voltage drop of the transmission line. V is the load bus voltage. Now we are interested to find load bus voltage. That is equal to, after rearranging the equation, we are getting V is equal to E minus JXI. Now look into the second equation. We are aware that S is the complex power or apparent power that is given in terms of P and Q, that is equal to P plus JQ, that is equal to VI asterisk. The asterisk represents here complex term, complex conjugate, VI asterisk. So that I can be obtained from the first equation. Here I is equal to, we can take this to left hand side and V to right hand side. Finally, I can be written as E minus V divided by JX. Now substituting I in this equation, VI complex conjugate, and taking complex conjugate, and rearranging, we are able to get the complex power, apparent power is equal to J by X into EV cos theta plus J EV sin theta minus V square. You can work out this simplification in your rough notebook. Let me repeat once again what we are doing here. Let me explain the steps briefly. So we have got equation for bus voltage, that is E minus JXI. From this we are getting equation for current, and we are trying to substitute this I in S, the complex power, and we are, after simplification, we get this equation. So let us number this as first equation and this is second equation. Now equating, what we are trying to do, let us on the left hand side we are having P plus JQ, right hand side we have this term. Now let us equate the real parts and imaginary parts separately. After equating real parts, we will have real power is equal to minus EV by X sin theta. How do we get this? J into J, it is minus 1. So J square is nothing but minus 1. Therefore, we get minus EV by X sin theta. And further, after simplifying, we will get this Q is equal to minus V square by X plus EV by X cos theta. Finally, we have got two terms. The equation for real power, that is equal to minus EV by X sin theta. And we have got one more term after equating the imaginary part. What is that? Q is equal to minus V square by X plus EV by X cos theta. Now we are trying to solve this equation. After appropriate steps, we are trying to get that V square, the whole square plus 2QX minus E square into V square plus X square into P square plus Q square is equal to 0. Now this is second order equation in terms of V square. Let us assume X is nothing but V square. So it will be, we can write like this. So our objective is to solve this equation. What is the solution? Let us see what is the solution which we are obtaining for this equation. How do we get this equation? Let me tell once again. What we are trying to do is we are trying to eliminate this theta term. How can we eliminate this theta term? Let us consider this is equation 3, this is equation 4. Let us square these two equations 3 and 4 and add both equations. What we'll get? P square plus Q square on the left hand side, and this term will be squared here. This also squared, A plus B the whole square. So you can apply A square plus 2AB plus B square. After substituting and simplifying, we will get this equation. Let me repeat once again. We have got equation for P, we have got equation for Q. How did we get P and Q? After separating real imaginary part in this equation. Now you try to square both the terms and add it. After adding, sin square plus cos square theta will become 1, and after rearranging, we will get this equation. I request you all to do in your rough notebook the simplification steps. Substitution and simplification can be done by yourself. Now, for that, we are aware how to solve a quadratic equation. We have got, we can take the coefficient of x square, then coefficient of x as b, then constant term c, a, b, c. With the help of this a, b, c, we have already found, we are aware that we have got a formula to find out the solution. B square minus 4ax, 4ac. B is nothing but 2qx minus e square. So b square, we are getting the first term, and a is coefficient is 1, and c we have got this equation x square, p square plus q square. So finally we get this equation. This term is nothing but b square. B is this term within the bracket, and a is 1. Therefore 4 into 1 into c is x square into p square plus q square. So look at the previous equation. This here we are assuming x is v square. So x square will become, the coefficient of x is 1, that is a. B is this term, coefficient of x, and the constant term c is nothing but x square into p square plus q square. From this, we are solving this. We are trying to get b square minus 4ac greater than or equal to 0. Now we are rearranging the equation, or we are simplifying this equation further. Further simplifying, we will get this equation minus p square minus e square by x q plus e square by 2x the whole square greater than or equal to 0. Now what we are trying to do, we are setting or putting p is equal to 0. Further we can simplify, q is less than e square by 4x. What we try to interpret here is e by, we can separate this e square as e into e. Therefore it can be written as e by x or e into e by x. So 1 by 4th of, it is nothing but the short circuit power. Power is nothing but product of voltage and current. How do we say that it is a voltage and current? E is no load voltage and current is nothing but E divided by X. Therefore, 1/4 of this short circuit power. Now P is nothing but half of the term, half of that same E square by 2X. How do we get the value of P? By setting Q is equal to 0. Now from this, with the help of this condition and this equation, one can easily solve and try to get the relationship between power and voltage. We call this as PV relationship, or the equation which relates power and voltage. Now from this, after substituting, after doing simplification, we will get B is equal to square root of E square by 2 minus QX plus or minus, once again square root of is E to the power 4 by 4 minus X square P square minus X E square Q. So you can take time to get this solution, and this is the final equation which we are getting. This shows the relationship between power and voltage. Voltage depends upon the real and reactive power of the load bus. Now we have taken a 2-bus system. So with the help of this equation, we are trying to find out the value of load bus voltage for various values of loads, real power and reactive power load. Now with the help of this, one can easily draw the PV curve. From the PV curve, we can be able to find out the maximum loadability limit, as well as we can find out the real power margin, otherwise called as voltage stability margin or loading margin. Already we have discussed a lot about PV curve. You can refer to my previous video if you are interested to know it further. Further request you all to go through the textbook for better understanding. Thank you. Next video, I'll be discussing about the remaining topics. What are the other topics? We are going to discuss about static voltage stability indices. Thank you all.